Ulusal Kimya Eğitimi Kongresi'nin değerli katılımcıları merhabalar. Ben Doç.Dr. Hasan Özcan, Aksaray Üniversitesi Eğitim Fakültesi'nde öğretim üyesi olarak çalışmaktayım. Öncelikle bu kongrenin düzenlenmesinde ve sizlere ulaşmasında görev alan başta Sayın Rektörüm Prof. Dr. Semih Aktekin ve Kongre Koordinatörü Sayın Davut Sarıtaş Hocam olmak üzere tüm hocalarıma çok teşekkür etmek istiyorum. Bugün Ulusal Kimya Eğitimi Kongresi kapsamında Arjantin Buenos Aires Üniversitesi'nden Prof. Dr. Agustín Adúriz-Bravo ile kimya eğitiminde güncel yaklaşımlar ve olası görünümler isimli bir söyleşi gerçekleştireceğiz. Kendisi hem değerli bir meslektaşım hem de uzun yıllardır tanıdığım yakın bir dostum. Sağ olsun bizleri kırmadılar ve katılım gösterdiler. Bu söyleşinin sizlere faydalı olmasını diliyorum ve vakit kaybetmeden izninizle hemen başlamak istiyorum. Hi, dear Professor Agustín Adúriz-Bravo from the University of Buenos Aires in Argentina. First of all, I would like to thank you for accepting our invitation and taking part in the National Chemistry Education Congress as an invited speaker. Unfortunately, many scientific meetings could not take place due to the pandemic. For this reason, we are holding the National Chemistry Education Congress in Turkey remotely. You know that many of the Congress participants are watching us right now. Of course, some researchers might have seen you for the first time. Could you please introduce yourself briefly? Could you also talk a little bit about your field of interest and the research studies you have carried out thus far?
Yes, of course, my pleasure. Hi to everyone, thanks Hasan. My name is Agustín Adúriz-Bravo, I come from Argentina. I'm now in Buenos Aires, the capital, the biggest city down here. Okay, I pursued studies in physics education at the Universidad de Buenos Aires, University of Buenos Aires, in the 1990s. Okay, here is similar to the case of Turkey. We have a specific degree in physics teaching. It's different from what happens in Europe or North America, where you first get a degree in the science that you're going to teach, and then you move to postgraduate studies in educational sciences or studies. Here we have a specific degree in physics teaching or science teaching. It's called Profesor de Enseñanza Media y Superior en Física, which means that you are able to teach in lower and upper secondary schools and the equivalent to college. So I got my degree in physics teaching in the 1990s from Argentina. Then I moved to Spain, to Barcelona. Back in those times, there weren't many programs of PhDs in didactics of science, science education here in Argentina, so I had to move abroad. I went to the Universidad Autónoma de Barcelona, the Autonomous University of Barcelona, where I pursued my PhD studies under the supervision of Professor Mercè Izquierdo Aymeric, who is a very well-known didactician of science, of chemistry. She's a specialist in the use of the history and philosophy of chemistry in chemistry education. Although I come from the background of physics, my degree is in physics, I studied chemistry education with her. That's why I have productions and publications in chemistry education as well. Then I did a postdoctoral postdoctoral studies back there in Barcelona too, with Professor Ana Estany, who is a very well-known Catalan philosopher of science. And then I came back to Buenos Aires in 2002, where I established at the Universidad of Buenos Aires an institute called CeFIEC. It's an institute for didactics of science, history and philosophy of science, very well known here in Latin America. There I founded a research group called GEID, Grupo de Epistemología, Historia y Didáctica de las Ciencias Naturales, a group for research in science education with the aid of the philosophy and history of science. My area of research is precisely the contributions of the history and philosophy of science to science teaching. I work with all the natural sciences, physics, chemistry, biology, geology, etc. And for all the educational levels, from kindergarten to university, my main focus is in pre and in-service science teacher education. And within this umbrella of research in the contributions of history and philosophy of science for science education, I have several research lines with my group, with my collaborators, senior and junior scholars, and PhD and master's degree students. We work along the following lines: nature of science, preparation of teachers in the philosophy of science, school scientific argumentation, school scientific models and modeling, inquiry, the role of inquiry in science education, scientific competence of inference, thinking, and discourse, and the use of narratives and science stories in the teaching of science. With the group, we work in all the education levels, as I told you, but my main focus of my line of research is with teachers. So I implement all these lines that I told you with prospective and in-service science teachers. Some of them are chemistry teachers. I know the community of chemistry teachers in Argentina very well. We have a local conference just like yours now. It's much smaller than yours, of course, but we have this conference for chemistry teachers every 2 years, and they have a journal for innovation in chemistry teaching. My main interest now is in the production of explanations and argumentations. This is a point where we have collaborated recently, and we hope we are going to collaborate with you further on. I'm interested in the nature of scientific explanation and how the philosophy and history of science collaborate in the construction of sound, well-founded explanations in the classroom.
Okay, thank you, Professor Agustín. Now, if you want, you can talk about scientific issues a little more deeply. You know, chemistry education is much younger than the field of chemistry. Of course, it's nature, but I'm curious about your ideas on this subject. So, what do you think about the historical development of chemistry education in the world?
That's a good and interesting question for the audience, the participants in the conference. Of course, chemistry is a very old science, perhaps from the late medieval times or early modernity. And chemistry education is just an emerging discipline in the second half of the 20th century. Now, as you have told us, it's consolidated, it's emerged, it's mature as a discipline. We have been studying chemistry education for 50 or 70 years now. The emergence of chemistry education perhaps can be located between the two wars in Europe, between the First and Second World Wars. In terms of the independence, the autonomy of chemistry from quantum physics and the developments of German physics in between the two wars, there was an interest from some professors at the university in establishing a way of teaching chemistry with atoms. This is where I would locate an incipient and early chemistry education. It was, of course, only directed to university students, to a minority, to an elite of students who were going to be chemists afterward. After World War II, in the 1950s, there was this great movement of curriculum reforms all over the world. New curricula emerged because the great powers in the North, United States, UK, etc., needed more people into science and technology. They needed people prepared, formed, educated in science and technology. So they began an aggressive campaign to scout for young people who wanted to go on studies in science and technology. In these times, there was some kind of scientific research on how chemistry could be taught more efficiently. These were probably quantitative studies of great size, very encompassing and ample, and they had to do with new chemistry curricula and new methods in the classroom. After that, in the 1970s, there was this big invention, this great idea that some science educators had back in those times. They invented the idea of misconceptions and conceptual change, and this moved forward our field, and this is the formal origin of science education. At the same time, chemistry education was being developed side by side to general science education because there was interest in the issue of models and modeling in chemistry. For instance, we have the figure of Professor John Gilbert in the UK, who recently passed away. He was one of the first scholars to study these issues of how models and modeling could affect the teaching of science. So I would say that in the 1970s and 80s, you had at the same time the development of science education, didactics of science, as we call it in Europe and Latin America, and the emergence of chemistry education done by chemists, by professional chemists, who were interested in the issue of models and modeling, representations, and semiotics in chemistry classrooms.
Okay, thank you. In connection with my previous question, what would you like to say about the relationship between chemistry education and trend efforts? How and where did it evolve? We can now start from the example of Argentina.
Okay, I think it was developed at the same time by people who were in the classrooms of the different educational levels, and in the case of chemistry, most teachers are in the secondary level because chemistry in primary and pre-primary schools is integrated into natural sciences or experimental sciences. So the first interest was from teachers of upper secondary school, attending or teaching to children between 15 and 18 years old. And of course, in the college and university levels, where there was this issue of capturing people to study chemistry, professional chemistry, and maintaining these people in the university, because many of them would abandon their careers because of the complexities of chemistry or because they were inserted in the local workforce, in the work market, with some knowledge of chemistry, which was not the entire career at the university. So I would locate the emergence of these issues in our countries, in third world countries. We were before third world countries, Argentina and Turkey, and now we are emerging economies. In these interests, in these parallel interests in the secondary school, where chemistry was recognized as a difficult issue, and in the university, where they needed to scout and capture young people to pursue chemical studies. It was in these locations and with the aid of ideas coming from study of the nature of the particulate nature of matter, with tools coming from psychology, from cognitive psychology, learning psychology, etc., that chemistry education emerged as a field of innovation, not only of research, but also as a field of innovation, which is, I suppose, the main point that many people in the audience would be interested in, how we can transform our chemistry classrooms in the different educational levels.
Okay, thank you, Professor Agustín. Again, I know your work on the integration of chemistry education with STEM education and the history of philosophy of science. We would like to learn a bit about this integration by the help of some examples.
Great. This is interesting for the audience because we talk at a theoretical level and we produce papers and pieces of research and ideas, and these need to be related to real classrooms through examples. What we do with the philosophy and history of chemistry is very diverse. We do many different things that can be interesting for the audience. First of all, we do a philosophical or epistemological reconstruction of the science to be taught, or the chemistry to be taught. we consider that school chemistry, whichever the level you are teaching, might be primary, secondary, or even college and university, is not exactly chemist's chemistry. It's a different thing. It has epistemological nuances. It is a reconstruction of chemistry. So we talk of didactical transposition. It's a very well-known idea from French didactics. And we need to examine the nature and function of chemical entities in chemistry education. So this would be one big issue that you can do with the philosophy and history of chemistry, a sound or well-founded reconstruction of school chemistry. Inside this line of chemical reconstruction or philosophical reconstruction of chemistry, we also examine the nature of practical work, of lab work. And this is something in which we have collaborated already with you and the boot. In the line of reconstruction of the nature and role of experiments, chemical experiments, in primary, secondary, and university chemistry education. This is one point. Then we use the history and philosophy of science to understand, as I told you before, the nature of explanation in chemistry. That's explaining in chemistry mean. How you use entities in the macro and the micro levels at the same time, and how you articulate explanations that are macro, related to substances and chemical change, and that are sub-micro, related to atoms and valence and bonding, etc., etc. So we need also an epistemological perspective, philosophical and historical perspective, on the nature of the entities and relations that constitute chemistry in both of these levels of teaching and of thinking. Then we also try and understand, with the help of the philosophy and history of chemistry, the nature of the discourse of chemistry, the language of chemistry. Especially, we can examine the nature of argumentation in chemistry, how chemists argue when they explain, when they produce new ideas, and when they interpret phenomena in the world. And of course, another line would be to use historical elements supported by a good view of the nature of the scientific method coming from the philosophy of science to understand historical events in chemistry and produce narratives and science stories where these events can be used to teach chemistry to students or to prepare teachers in chemistry teacher education. Some concrete examples. We, for instance, have used very extensively the life and achievements of Maria Salomea Skłodowska-Curie, Madame Curie, to see how she proposed the existence of two new elements, radium and polonium, when she was studying Bohemian pitchblende at the end of the 19th century. So we talk about the invention of radium, not the discovery of radium, what is usual in the textbooks, but we talk about the invention of radium. We talk about the abductive nature of inference in her studies, how you can propose a hypothesis, a hypothetical entity, a new radiometal very active that is diluted in pitchblende, and you then move to identifying this new metal and to characterizing it and locating it in the periodic table of the elements. Another example would be to use historical events like phlogiston and oxygen, the debate around phlogiston and oxygen at the end of 18th century, to understand these nuances and details of explanation in chemistry, how you explain when you resort to entities that are not really existing, like those in the micro or sub-micro level, that you postulate entities that mediate between the world of substances or materials that you can control and transform and the world of semiotics, the world of the symbols and signs that you use to control those changes that you do to matter. So these will be two big examples of how we proceed in chemistry education. We have also studied some aspects of oxidizing and combination with oxygen, some things about acids and bases, some things about the nature of atoms in the late 19th century and the beginning of the 20th century, some aspects of radioactivity and radiochemistry, the idea of the particulate matter of chemistry in real cases in the real world, how students can use this powerful idea to make sense of phenomena that are around them, how they can proceed. And of course, in the last 2 years, we can use these ideas, these chemical ideas, in the case of COVID-19, because we can talk about how to prevent from the disease and disinfect surfaces, hands, air, etc., or to talk about nature, the biochemical nature of the virus and its functioning in the human body, and of course, some chemistry of vaccination and prophylaxis and medication, etc., etc.
Okay. Thank you, dear Professor Agustín. Another issue I'm curious about is the future of chemistry education. What do you think about it, and what would you recommend to our young colleagues?
That's a great question, and it's a very difficult question, and I will give you my opinion, which I think is well-founded on what we do and how we interact with other groups in the world that do chemistry education. But of course, it's not the revealed truth. It's just an informed opinion of how I see the evolution of our field in the next 10 or 20 years. I think, on the one hand, we have been developing or going deeper into the traditional lines. And among these lines of research, the classical lines, is models and modeling. I think this is one line that has lots of future ahead and can be developed and applied into chemical classrooms. And it's absolutely valid today, and lots of things can be done in the next future. So I sort of see that models and modeling will continue being one of the strongest lines in chemistry education. Along with this, we also have this investigation into the particulate issues and the nature of atoms and how atomic chemistry relates to substance chemistry. This line, which is, for instance, cultivated in the Netherlands and France and the UK, will continue being one interesting line. On the other hand, I see that parallel to this that I have spoken of, will be emerging some new research lines and directions related to the new integration of chemistry with other disciplines and subjects. For instance, STEM and STEAM proposals, science, technology, engineering, mathematics, plus arts, will redefine the borders and horizons of chemistry education. So perhaps inquiry in chemistry education, competencies, chemical competencies, and STEM and STEAM will be new foci of interest in the community of chemistry education, which will force chemistry educators, didacticians of chemistry, to reform and transform their theoretical background or their theoretical frameworks, because now chemistry is going to be integrated, more integrated with the other natural sciences and with mathematics. So perhaps we'll see in the near future new interests related to chemistry for citizenship, chemistry in decision making, and chemistry for social justice that were timidly emerging in the last 20 years because of the reforms of the curricula and the idea of competence and the documents in the European Union, but will now be stabilized and will be deepened, and we'll see a new school chemistry that gets away from chemistry and goes deeper into issues that are more related to citizenship, like sustainability, health, food, energy, the future of mankind.
Thank you. That's understood. You shared your invaluable experiences with us. On behalf of the Congress officials and participants, thank you very much. I think that I tried you a lot. Please, for you, finally, if you have something to add, please do not hesitate to do so.
Thank you very much, Hasan. What I would like to add has nothing to do, or has something to do with chemistry education, but it's not directly related to the academic field. It has to do with the need for collaboration between countries that are out of the axis of scientific power and domain and publications. And this is how Turkey and Argentina can collaborate further on, because we are emerging countries with lots of people who have preparation and good background, lots of human resources of high quality. We are populated countries, more or less rich countries if we compare to the rest of the world. We have very large educational systems, and we are occupied and preoccupied of the education of young people. We have more young people than first world countries because our population is not as old as in the first world countries. So I think there is lots of room for establishing collaboration between these countries, especially now because we are here between Turkey and Argentina. I think the future of didactics of science and didactics of chemistry will go through these lines of international collaboration out of the northern axis of the Atlantic Ocean, out of the dominating countries that have published a lot and are the usual suspects when it comes to publications. So I think we need to overcome the barriers of language and the distance and things like that, and think about sharing ideas and experiences that are that have points in common, that are similar in many aspects. Of course, we have two different cultures, and we are very different countries, but we have many points in common, many commonalities, and we should explore those in collaborations for the improvement of science and chemistry teaching in our classrooms. That's what I wanted to say, and I wanted to thank you personally and all your colleagues for the invitation.
Thank you, Agustín. Thank you very much for spending your precious time for us and for your participation. As Turkish people, we are hospitable and we like guests very much. I hope we have the chance to host you in Cappadocia or Istanbul. I hope so.
I can come to Cappadocia in the near future.
Yeah, okay. I hope to see you again at another scientific meeting and benefit from your invaluable experiences.
Thank you very much. Thanks to you.
Thank you.